So basically that will be the topic for today, resultant of two vectors. Right. See, we all know that displacement is a vector quantity, right? So let's consider two displacements. Let's say a person starts from here, like starts from A, goes to some point B. Okay. Path does not matter for displacement. It's only the initial and final positions. Okay. So let's say person starts from A, goes to some random point B, and from there the person goes to some other point C. So the person started from A and finally ended up at C. So we know the effective displacement. It is from A to C. But the effective displacement is a combination of two separate displacements. Let's visualize those separate displacements first. A to B is one of them. Let's call this as the first displacement, S1. And B to C is another displacement. Take that as the second one, S2. Generally, we know that effective displacement or total displacement of an object is the sum of small displacements, right? It's a known thing in motion in a straight line also we had discussed. Here, total displacement is the displacement from A to C. So you must say that this third vector that we have drawn, S3, it's the sum of the first two vectors, S1 plus S2, because that third displacement is the sum of the first two displacements. So the third vector that we had drawn here is the sum of the first two vectors. Now see, S1 is one vector, S2 is one vector, S1 plus S2, their resultant is also a vector. And when you observe these three, two vectors and their resultant, you can clearly see that they form a triangle. So this is a very important rule in vectors, or observation in vectors, you can say. Two vectors and their resultant always form a triangle. Fine. Now, if you observe the first two vectors, S1 and S2, which we took as the two displacements, the tail of S2 is at the head of S1. Okay. So if you go along the first vector and then turn in the second direction of second vector, you will get a particular order. S1 and S2 are following this order, you can say, or they are placed in order. What do you mean by placing vectors in order? Tail of the second vector should be at the head of the first vector. Then suppose there's a third one. Tail of the third one should be at the head of the second one. When you arrange vectors like that, they are said to be placed in order. Okay, hope this point is clear to all of you. Now, when two vectors are placed in order, their resultant, okay, you can consider these two. Okay, we'll talk about the resultant a little later. Two vectors placed in order, if you consider them as two sides of a triangle, then their resultant will be the third side of the triangle formed by them, and that resultant will be in, as you can observe, it's in the reverse order. AC is the resultant, right? It's in the opposite order to the order that S1 and S2 are following. Fine. So when two vectors placed in order are considered as two sides of a triangle, their resultant is the third side of the triangle drawn in reverse order. Okay. This is something we call as triangle law of vector additions, addition. This allows us to visualize the resultant easily. Okay. Fine. Statement I'll type later and send. So if two vectors placed in order are taken as two sides of a triangle, then the third side drawn in reverse order becomes their resultant, always. Okay. And you can extend this to any number of vectors, not just two. And here we consider displacement as the quantity, right? We know that if one person goes from A to B and then from B to C, the net displacement is from A to C. We know that. But this is observed to be true for all vector quantities. What I mean is, suppose there is one force acting this way, and simultaneously, means at the same time another force acts this way, then the resultant force on the body will be in this direction. Okay, means if an object, okay, I'll write the statement of triangle law here later. If an object is pushed by one force like this in this direction and another force at the same time in this direction, then effectively it will end up moving, or it will behave as if, or the combination of the forces will make the body move this way. So if this is one force F1, this is one force F2, then this is the resultant of the two forces. Okay, makes sense, no? You imagine an object, one person trying to push it this way, another person trying to push it this way. Effectively, it will go in the somewhere in between, no? That is what we mean by the resultant of two vectors. Okay, so if you ever want to visualize the resultant of two vectors, take them in order first, put them in order. What do you mean by putting them in order? The second one's tail should be at the head of the first one. Once they are placed in order, you take them as two sides of a triangle, then the third side in reverse order will become their resultant. Okay, and it doesn't matter which vector you take first. Okay, I'll show you that also. Here we took S1 followed by S2. Even if you take S2 first and make S1 follow it, like draw S1 in order, sorry, like this. So take S2 first followed by S1. Now they are in order. Tail of one vector is at the head of the next. You will see that the resultant will still be the same. I'm simply copy pasting it and I can adjust that it fits exactly here. Okay, it will become the third side of the triangle. So the black vector in both cases is the same. So it doesn't matter which vector you consider first or which vector you consider second. Take two vectors in order as two sides of a triangle. Then the third side in reverse order will be their resultant. It will always be like that. So this is called the triangle law of vector addition. And we consider two vectors here. It need not only be two vectors. You can extend this to any number of vectors. Consider something like this. Let's say a person starts from here, A, goes to B, then to C, then to D, and finally to some other point also. Doesn't matter. Okay, any number of points you can take. So this person is undergoing a set of displacements. First displacement is from A to B. Okay, that is one vector. Next displacement is from B to C. We can represent that by another vector. But notice that the tail of the second vector is at the head of the first. Means they are in order. Then he goes from C to D, he or she, and so on. These are the set of displacements the person undergoes. So this is the first vector, second vector, third vector, and so on. And the way we have drawn, they are all in order. Okay. Now, what is the total displacement of the person? Total displacement is from A to D. And we know basic physics that total displacement is the sum of individual displacements. right? So in terms of vectors, if you see that orange vector is the resultant of all these blue vectors. And how many blue vectors have we taken? 3. You can take 2, 3, 4, any number of vectors you want, but ensure they are placed in order. Tail of the second at the head of the first, tail of the third at the head of the second. Once they are all placed in order, you will see that one tail will be free finally, and one head will be free. After keeping all of them in order, one tail and one head will be free. Connect them, that will be the resultant. Okay, this is something we call as polygon law of vector addition. Okay, statement I'll type and send later. So if you take a set of vectors in order as the sides of a polygon, once they are all placed in order, you will see that one tail and one head will be free. Connect them, that will be the resultant, that will become the resultant. And that resultant will be in reverse order. You can see these are the original vectors are all following kind of anti-clockwise order. The resultant will be in clockwise order. That is the reverse order. So triangle law, polygon law, they are effectively the same. Triangle law gives you the resultant of two vectors. Polygon law can give you the resultant of any number of vectors. Okay, at least it can help you imagine the resultant. And as I said, here we use displacement as an example. Even if there were 3 forces acting on an object like this, or an object simultaneously has 3 different velocities. Okay, for example, you consider an ant. Let's say an ant is moving on a paper. Ant has its own velocity on that paper. But if you move the paper, that velocity gets added to the ant. Okay, and you can find out the effective velocity of the ant like that. So any vector quantity, if you want to add vectors, you can follow these laws. So one is triangle law, the other one is like triangle law is for 2 vectors. For any multiple vectors, you can use polygon law of vector addition. Okay. Then there is something called parallelogram law. Of vector addition. It is just a restatement of triangle law, I would say. Let's consider these vectors only. Let's draw the original vectors in blue. Right. You can see the vectors and the resultant already. But parallelogram law gives you the resultant in a slightly different manner. In triangle law, what we do is we take the vectors in order, right? That is very important for application of polygon law or triangle law. Tail of the second should be at the head of the first. But for parallelogram law, what we do is we make their tails coincide. Okay, so using this diagram itself, we can show. Take one vector as one side of a parallelogram. Take the other vector as another side of a parallelogram, but with the tail being at the same point, same position. Both of them should have tails at the same position. It's like that. So basically, this was one displacement S1. This was another displacement S2. Now they are not in order because tail of one is not at the head of the other. You don't call this as being in order. But you imagine these as two sides of a parallelogram. Then finish the parallelogram by imagining the other two sides. You can do that, that's not a big deal. So assume this is the parallelogram formed by the vectors S1, S2. See, parallelogram has 4 sides. But we say that this parallelogram is formed by the two vectors S1 and S2. Two vectors are enough to form a parallelogram because the other two are parallel to these. So they don't have to be specified separately. You specify two sides, that's enough for a parallelogram. The other two sides are known to us. Okay. So we call this as the parallelogram formed by the vectors S1 and S2. And their resultant now, it's obvious, you can directly see it here. The resultant is nothing but the diagonal of that parallelogram. I just copy pasted this. So no change in length or direction, anything. This one and this one are the same. So on the left, what you are seeing is triangle law. On the right, what you are seeing is parallelogram law. So when do you use triangle law to visualize the resultant? When the vectors are in order. Means tail of one is at the head of the other. When to draw resultant using parallelogram law? When both tails are at the same point. Okay. So these are called co-initial vectors. Means their initial point is the same. Okay. So remember, triangle law or parallelogram law, they give the same resultant. The way you draw the resultant is different. Is this clear to all of you? Any doubts in this? Okay. See, in these things, practice is very important. So tomorrow also you'll have a class. No, day after tomorrow, I'll send you a worksheet where you'll draw a number of vectors and their resultants. Okay. Fine. The next thing we are going to discuss today is how to find out the length of this resultant. How much will the combined effect of two vectors be? Now, using parallelogram law or triangle law or polygon law, we can visualize the resultant. But how long is it actually? That calculation we will do for two vectors. Okay. So let's consider two vectors first. Let this be the first one. Let's call it as A. And magnitude of the vector A, let's simply call it as small a for now. Okay, I told you modulus represents magnitude. Let's call it as small a. Consider another vector. Let's call this vector as B and its magnitude as small b. Okay. Now when two vectors are arranged this way with their tails at the same point, then whatever angle they make is called the angle between the vectors. Theta. Theta is the angle between them. We'll discuss in further detail about angle between vectors. But for now, see, A is indicating this direction, B is indicating this direction. The angle between those two directions is theta. Okay. Now, since their tails are at the same point, Pawan, tell me, which law should we use to draw their resultant when tails are at the same point?
Sir, parallelogram law.
Parallelogram law should be used. Correct. Let us do that. Complete the parallelogram. This will be the third side, and somewhat like this will be the fourth side. Or for fourth side, actually, I can copy paste B. For third side, I could have copy pasted A. Yeah, this will make it look more accurate. Right. So that's the parallelogram formed by these vectors A and B. Okay, as I said, parallelogram has four sides, but if you know two sides, okay, two adjacent sides, that's enough. The other two sides are known to us. So we can say it's the parallelogram formed by these two vectors. Then their resultant, using parallelogram law, how do you draw the resultant? From the common starting point of the vectors, you draw a diagonal to the opposite corner. Of course, diagonal has to be drawn to the opposite corner only. So that becomes the resultant vector. Let's call it as R for now. So you can say that R vector is A vector plus B vector. It indicates the direction of their combined effect, and its length indicates the magnitude of their combined effect also. And its length is what we are trying to find out now. So what all do we know here? We know A's length, we know B's length, and we know the angle theta between them. In terms of these, our aim is to find out the magnitude of the resultant. So we'll be using some geometrical constructions here. Just extend A along its own direction and drop a perpendicular from the opposite corner onto this. These are just some extended lines that we have drawn. Okay. Now let's mark some points. Call this as, okay, let's call this as M, N, X, Y. Now N to Y is same as B. Okay, if this side's length is B, then N to Y will also be B itself. Fine. And NXY, that angle NXY is 90 degrees. This one. We intentionally dropped a perpendicular there. Fine. And you can see the vector B, the original vector B and the side NY, they are parallel. Then this line MN becomes a transversal and this angle will also be equal to theta itself. What are these angles called? This one and this one. Like if there are two parallel lines, this is the transversal, then this angle is same as this angle. What do you call those angles? Corresponding angles. Is that the name or anything else? You would have studied in mathematics, no? That's why I'm asking. Okay, fine. If you don't remember, leave it. I think they are called corresponding angles only. Anyway, now observe this triangle. Which one? NXY. I'll draw it separately. It's a right angle triangle. We can see that clearly. And in that right angle triangle, B is the hypotenuse. For the angle theta, NX is the adjacent side. NX is adjacent side, B is hypotenuse. We can say that cos theta is equal to adjacent, that is NX, divided by hypotenuse, that is B. Therefore, the side NX becomes B cos theta. Is this step clear to all of you? If you have any question, you can ask. Okay, so this length becomes B cos theta. And this base is already equal to A. Fine. Now consider this big right angle triangle. Which one? This one. So M, X, Y. Okay. So in this diagram, basically we are considering this right angle triangle. Okay, I've taken it separately here. And in a right angle triangle, we know we can apply Pythagoras theorem to relate the sides. Can any of you quickly tell me Pythagoras theorem?
Sir, hypotenuse square is equal to oblique square plus adjacent square.
Square of hypotenuse is equal to square of opposite plus square of adjacent, correct? Okay, we got B cos theta, we didn't get the other side, no? In that small right angle triangle, that opposite side xy, that can be derived as sine theta is equal to opposite by hypotenuse. So xy becomes B sine theta. That we can write here. Okay, so this is B sine theta. Right. So Pythagoras theorem, hypotenuse, that is my square, is equal to sum of squares of the other two sides, mx square plus xy square, you can write. Now our aim in all this is to derive the length of the hypotenuse, because that hypotenuse was nothing but the resultant. Okay, so what we want is my. Fine. So we can write this as r square, square of the resultant, is equal to mx. How much is the distance from m to x? How much is the distance from m to n? M to n is a, and b cos theta gets added to it. So becomes a plus b cos theta whole square. That is mx square. And then xy square. Xy is nothing but b sine theta. Square it. Simple. So r square becomes a square plus 2ab cos theta plus b square cos square theta. And from the second bracket, you get b square sine square theta. In these two, if you take b square common, you'll be left with cos square theta plus sine square theta, which I am sure you all know is equal to 1. Therefore, the square of the resultant becomes a square plus b square plus 2ab cos theta. Or you can say only resultant becomes square root of a square plus b square plus 2ab cos theta. And this is what we expected yesterday. The length of that resultant vector should depend on lengths of the individual vectors, that is a and b, and it should also depend on the angle between them, theta. So this is how you calculate the magnitude of the resultant. But remember, this is restricted only to the resultant of two vectors. If there are more than two vectors, like more than two forces acting on an object, more than two displacements that an object undergoes, you can't use this to find out the resultant. Okay, so small a here was the magnitude of the first vector, like magnitude of one of the vectors. Small b was magnitude of the other vector, and theta was the angle between them. And remember, angle between two vectors must be taken only when their tails are put together. You can't put one tail and one head together and call that as the angle between the vectors. Like in this diagram itself, you see, I'll draw in yellow. This vector is b. This vector is a itself. Okay. It will appear as if, I mean, you here, if you see, you'll get some other angle. This is not theta, right? And that angle alpha is not called the angle between the vectors. Angle between vectors is the angle between the directions that they show. A is showing this direction. B is showing this direction. This is the angle between them. So small angle, it will be that small angle, theta. So remember, whenever you take angle between two vectors, you have to imagine their tails joined together. Okay, let's work on that first, and then we will solve a few problems involving this formula. Okay. Basically, it's the angle that appears when their tails are put together. It is a rule, okay, that only when tails are together, whatever angle you see is the angle between the vectors. So, okay. Fine. Let's consider two vectors like this. Let's say one of them is this way. One is like this. Now their tails are put together, okay. Even when you put tails together, you will see two different angles, this one and this one. Now, by convention, means as a standard understanding, we always take the smaller angle as the angle between the vectors. Okay, so this is called the angle between the vectors, and it, when we say smaller, it's basically less than 180. Okay, angle between two vectors should always be less than or equal to 180. It cannot be more. You will never take that other angle. Okay, so theta, that is the angle between two vectors. I'll mention it here. Can only lie between 0 and 180. It can be equal to that, not an issue, but it can never be more than 180. You should never say two vectors are inclined at an angle 270 degrees. No. Okay, fine. Now, suppose there's one vector like this and another vector like this. Assume this angle is given to you. Let's call these vectors as A and B. Assume this angle is given to you as 140 degrees. Tell me, is 140 degrees the angle between these two vectors? Are the directions shown by these vectors having an angle 140 degree between them?
No, sir.
Okay, how much is the actual angle between these vectors?
Sir, 40 degrees.
It will be 40 degrees. Okay. Now, how did we get that number 40? First, let us discuss why it is not this 140. Here you can clearly see that the tail of one vector is at the head of another vector. When one tail and one head are joined, the angle that appears is not the actual angle between the vectors. You have to think of the directions that they are showing. A is showing this direction. B is showing this direction. This becomes the angle between the directions. And clearly it is less than 90 degrees. Okay. So to properly visualize the angle between two vectors, put their tails together. So I'll take the vector as vector B as it is and slide it. If you slide without changing orientation, the vector remains the same. So this is also B vector itself. Now A and B's tails are together. This angle that you see between them is what you should call as the angle between them. And if that is 140, this will become 40 degrees. Again, the parallel lines transversal. Or you can slide A also, then it will become even more easy to visualize. Any one vector you slide such that their tails coincide. So if I slide A here, then we can clearly visualize. We know total angle is 180, then this becomes 40. So that's the proper angle between these two vectors, 40 degrees. Okay. So solve this question, all of you. I'll just draw some vectors, find out the angle between each pair of vectors. Then you can slide vectors without rotating them. That won't change the vector. This is vector B, perpendicular to y-axis. Then there's another vector C. Assume this is 45 degrees. Yeah. Calculate the angle between A and B vectors, angle between B vector and C vector, and also the angle between C vector and A vector. You can draw them with their tails at the same point and then calculate the angle. A little bit of mathematics you'll have to use. Just some geometry, that's all. Type your answers in chat, all three of them at once. Why is it taking so long? I didn't get one answer. Okay, I got one. Yeah, vanilla, your answers are correct only. Pawan, your answers are correct only. Aishwarya, imagine A and B with their tails joined. Okay. B is exactly directed to the left. Just a moment. I'll copy paste B. So this is a replica of B. We are sliding it here. Why we are doing that sliding? To properly imagine the angle between A and B. So now can you tell? I'll push C aside. Just a moment. Yeah. Now can you tell the angle between vector A and vector B, Aishwarya?
So 150.
That's all. Okay. So it will be this angle, 150 degrees. Correct. Then between B and C, if you want, let's keep C somewhere here. It doesn't matter where you keep them. And then let's slide B such that its tail coincides with that of C. And the angle between them is clearly visible. It is 45 degrees. So that imagination you'll have to do. That's all. Then between C and A, okay, let's take C to where A is present. So I'll make a replica of C. So what I'm doing is I'm just sliding C to some place such that the tails of A and C coincide. Let me remove that orange one. Yeah. Aishwarya, tell me, how much will this angle between A and C now be?
So 105.
Yeah. Total angle in a straight line is 180 degrees. Remove 30, 45, you will be left with 105 degrees. So that is how you are supposed to take angle between two vectors always. Okay. Angle between vectors is the angle between the directions they indicate. And to properly visualize angle between vectors, you must ensure that their tails are at the same position. Even if their heads are at the same position, you will get the same thing. But those arrows will be there. No? It will make the diagram a little clumsy. That's all. So it's always best to take tails at one point and get the angle between two vectors. Fine. Next, let us use that resultant formula. We know that R, that's the magnitude of resultant of two vectors, that's the length of that resultant vector, okay, will be root of A square plus B square plus 2AB cos theta, where A and B are the magnitudes of the individual vectors whose resultant we want to find out. Theta is the angle between them. Okay. Now consider two vectors like this. Let's say one vector's magnitude is 10 units. Another vector's magnitude is also 10 units. And they're at an angle 60 degrees. Okay. Okay, even if you draw, I won't be able to see. If possible, you draw their resultant first. Now see, these are two vectors whose tails are joined. So any one of you tell me, which law should we use them? Yes, which law should we use to draw their resultant? Triangle law or parallelogram law? When tails are at the same point.
Parallelogram.
Parallelogram law. Okay. When tails are placed together, you finish the parallelogram like this. And then you draw the diagonal that becomes the resultant. Now our aim is to find out the length of that diagonal, magnitude of that resultant. Okay. So use that formula and tell me the magnitude of the resultant, all of you. Type your answers in chat. This is the first question. Next question, one vector 20 units magnitude, another vector 10 units magnitude, angle between them is 90 degrees. Tell me the magnitude of the resultant. Aishwarya, how much is the answer to the first one?
Sir, root 300.
Root 300. Okay, fine. Root 300 can also be written as under root 3 into 100. Now you split them. Root 100 is 10. So you can write it as 10 root 3. Okay. Vanilla, second one.
Root 500, sir.
Okay. That becomes 10 root 5 units. So basically what we are seeing here is if there's a 10 Newton force and another 10 Newton force, two 10 Newton forces don't always give a 20 Newton force, don't always behave like a 20 Newton force. Like in this case, root 3 is 1.732. Multiply that with 10, it's about 17.3 units or 17.3 newtons. So a 10 Newton force and a 10 Newton force can result in a 17.3 Newton force also. That possibility is there. Okay, depending on the angle at which they act. Pawan, you tell me, suppose these 10 Newton forces acted in the same direction. How much will the combined effect be? If two 10 Newton,
20 newtons.
20 Newtons, correct. This formula also will give you the same answer. 10 square plus 10 square plus, okay. Aishwarya, tell me, what is the angle between these two vectors?
Sir, 0.
0, good. They're both pointing in the same direction. The angle between them will be 0, correct. So plus 2ab cos 0. Cos 0 is 1. So ignore that. 10 square, 200, another 200, 400. Root 400 becomes 20 units. So their combined resultant is 20 units. Possible. 10 Newton can result in 20 Newton. Or a displacement of 10 and 10 can give an effective displacement of 20. That's possible if they are in the same direction. But if a person undergoes one displacement 10 Newton this way, another displacement 10 Newton this way, then the total displacement won't be, meters. One 10 meter displacement this way, another 10 meter displacement this way, then the total displacement won't be 20 meters. It will only be 10 root 3 meters. That is 17.3 meters, like that. That is what we mean by resultant of two vectors. So these are not simple numbers that we are adding. We are adding quantities by keeping their direction also in mind. Okay, that's why we need this complicated formula to get the resultant or the combined effect of two vectors. And unfortunately, this formula is applicable only to two vectors. If there are more than two vectors that you need to add, you can't use this, but in subsequent classes, you will learn how to add. And next question, we are seeing that two vectors having magnitude 10 and 20, which are perpendicular to each other, produce a resultant of 10 root 5 units. This resultant's length will be 10 root 5 units. That is what we see. So if you want to find out the combined effect or the magnitude of the combined effect of two vectors, you use this formula. It's called the formula for resultant. We'll be using this very frequently. You will get quite comfortable with it. Okay. Now try to answer this using your logic, on logic. Two vectors are there of magnitudes A and B. Assume A is greater than B. We don't know about their directions, but their magnitudes are A and B. First question. What is the maximum possible magnitude of their resultant? Aishwarya, can you tell? What is the maximum possible magnitude of their resultant? You have to imagine, when will two vectors give the maximum possible resultant? Imagine the vectors that way and find out. Aishwarya, you tell me, when will two vectors give maximum combined effect? How should they be acting?
No idea.
Like suppose there are two forces. Let's say there are two persons pushing an object. Okay. Their aim is to make the object move as fast as possible. So you imagine two persons pushing an object and they have to make the object move as fast as possible. How should they push?
In the same direction.
Correct. They should push in the same direction. They should support each other. So same thing holds for vectors also. Force is a vector only, no? So same thing holds for all vectors. If you want two vectors to produce maximum resultant, they should be in the same direction. If they are in the same direction, angle is 0. So in this question, indirectly the angle is given to you as 0. Then tell me how much will the resultant be?
Say A plus B.
It will be A plus B, correct. So if you use the formula also, you will see that it is root of A square plus B square plus 2AB. For maximum resultant, angle is 0. So cos 0 is 1. So we'll put that aside. A square plus B square plus 2AB is A plus B whole square. So it's like under root A plus B whole square. The root and the square get cancelled. You will be left with A plus B. Makes sense. One vector of magnitude A, another vector of magnitude B. The resultant will have a magnitude A plus B. Okay. Next. Again, vectors of magnitudes A and B. A is greater than B. What is the minimum possible resultant they can have? You imagine when two vectors will give the minimum possible resultant. Again, think of that two persons pushing an object case. Two persons are pushing with some strength, okay? When will the combined effect make the object move the slowest? Anyone? How should the persons push the object such that it moves in the slowest manner, slowest acceleration?
In the opposite direction, sir.
In opposite direction. So indirectly here the angle is given as 180 degrees. Okay, when two vectors are opposite, the angle is 180 degrees between them. Then tell me, what is the minimum possible resultant of two vectors?
A minus B, sir.
It will be A minus B. Okay, because this time you will have cos 180 degrees. Cos 180 degrees is minus 1. Then it becomes root of A square plus B square minus 2AB. That is A minus B whole square, and root and square cancel. You get A minus B as the resultant. What do we mean by this? Let's say this is one vector and this is another vector. Now we know that tail of the second is at the head of the first, so they are in order, then their resultant will only be from here to here. So if the first one is A, the longer one, second one is B, the shorter one, then the resultant will only be A minus B. So two vectors will have minimum possible resultant when they are opposite to each other. They'll have maximum possible resultant when they are parallel to each other. So you can say resultant of two vectors will be greater than or equal to the difference between their magnitudes, and it will be less than or equal to the sum of their magnitudes. So it can be any value between these two extremes. So this is the minimum possible resultant of two vectors. This is the maximum possible value. Okay, we'll stop here for today. So what we have discussed is how to properly get how to first draw the resultant of two vectors. You can use triangle law, you can use parallelogram law also. And if there are multiple vectors, you can use the polygon law. Just put all the vectors in order, one after another. Then when you put them in order, you will see that one tail and one head will be free. Connect them, that will be the combined effect of all those vectors. That's how you visualize the resultant, okay? But if you want to actually find out how long the resultant is, we derived a formula for it. Remember this formula, we'll be using it frequently. Then we discussed how to visualize the angle between vectors. We discussed some applications of that resultant formula, right? So tomorrow you'll have class as usual. And tomorrow we'll be discussing something called component of a vector, how to take components, and how after that we'll discuss how to express a vector mathematically. Once we do that, then we can start with the second chapter, motion in a plane. Okay, thank you all. We'll continue tomorrow.
Thank you.
Thank you, sir.